So you welcome to today's class. We're going to look at the laws of indices, or rather the indices. So we're going to look at indices. Indices is our topic, and we're going to start with the laws of indices. Laws of indices. So that is what we're going to start with. So we remind ourselves some laws of indices. We remember the first law of indices was when we have base A raised to m, then we multiply with the same A raised to n, we are going to get A raised to m plus n. That is what the first law says. Then, if you are having A raised to m, then divide by A raised to, then we are going to have A raised to m minus n. So when we simply subtract the powers, but when we are multiplying, we add the powers. Then the third law is when we have A raised to m, then in brackets, then we multiply by n. We're going to have A m n. Simple terms, we are simply going to multiply there. So we shall have A m n that way. Now for the laws to hold, for these laws to hold, for the laws to hold, the base must be the same. The base must be the same. So you should never apply the rules when we have different bases. So when the base is the same, that's when you're going to apply the laws. And for any number, any number raised to 0 is 1. So any number that you're going to raise it to 0, your answer is always going to be 1. For instance, A raised to 0, you will get 1. So any number raised to 0, you're going to get 1. And any number raised to 1, you'll get that number. Any number raised to 1, you'll get that number. For instance, A raised to 1, you'll get A numbers like let's say 50 raised to 1, you're going to get 50. That one. So with that, we can look at some few examples for us to apply the laws and see how they work. So let us look at examples. So our first example is going to be 2 power x, power 6, then we multiply by 2 power 4. Then B, 3 power 10, we divide by 3 power 4. Then C 5 power 2 brackets, then multiply by what? Power 3. So those are the 3 examples I want us to look at. We can see, look at the solution for those examples. Solutions. So A, we have 2 power 6, then multiply by 2 power 4. That one means that we are going to add the powers, not now that we are multiplying. Now we can apply the law that says you take the add the powers. So we're going to add 2, 6 plus 4. So we're going to get 2, 6 plus 4, you get 10. And at 10, 2 raised to 10, you get 10, 24 as your final answer. So that is how we arrive at that answer. Then having B, so B we have 3 power 10, then you divide by 3 power 4. Now we have the same base, we can apply the law. So we take 3 as the base. Then now that we are dividing, we subtract the powers. So you have 10 minus 4. So you 3 raised to 6. And 3 raised to 6, you get 729. That one becomes your answer. Then we have the C, our C, 5 raised to 2 into brackets raised to 3. Now applying our third law, we can say 5 raised to 2 times 3. We multiply the 2, therefore we have 5 power 6. And 5 power 6, you are going to get your answer as 15,625. So that is how we arrive at those answers. So you can see how the workings are easy. Let us look at more examples. More examples on the same. So we have this one, solve, we can say solve for x, Now A we have 2x raised to x, and then brackets power 3, then is equal to 2 raised to 12. Then B, 4 raised to 3, brackets, then you multiply by x, that is raised to x, is equal to what? 64. Then C, we have 9 raised to x, which is equal to 729. So those are the other few examples that we have to look at, how we can work them out. So straight to solutions on how to solve these ones. So the solutions is, now we get 2 power x, then brackets multiply the power of raised to 3 is equal to 2 power 12. Now as you can see, we can, using the third law, we can now solve this, the first part, and it will give us 2. Now we multiply the power x times 3x, you get 3x will be equal to 2 power 12. Now we have the same base, we are equating the same base. Therefore, we can now equate the powers alone, leaving the base now that we have the same base. So equate the powers alone. So we have 3x is equal to 12. Divide by 3, divide by 3. So x becomes what? 4. So our value of x becomes 4. That is how we get 4. Then for this other one, b, which we have 4 raised to 3x, 3 into x, so is equal to 64. So you multiply the powers, so we shall have 4, 3 power 3x is equal to 64. Now this 64, what you have to do with it, now that we have base 4, you have to make 64 to base 4, so that you have 4 raised to 3x will be equal to, now 64 is the same as 4 raised to 3. So 4 raised to 3 is the same as 64. So we've made the two sides to have the same base. Therefore, we can now equate the powers alone, so that we have 3x is equal to 3. So divide by 3, divide by 3. Now our x is equal to 1. So the value of x becomes 1 that way. So that is how we find the value of x in our second example. We can move to the third example. The third example. Okay, third example. So we have c, 9 power 2x is equal to 729. So this one now you have to make 729 to base 9, so that we have the same thing. Then we put the, so we have 9 power x equal to 729 to the same to the base 9 will give you 9 power 3, so that we have we equate, we drop the bases which are the same, then we equate the powers, which you have 2x, which is equal to 3. Now divide by 2, divide by 2. Now your x becomes 3 over 2, which is 1 and half. So that is how you arrive at the value of x, which is 1 half, 1 and a half. So that is it is that simple to work those using the laws of indices. Okay. The something else, what we call negative indices. We can look at negative indices. Negative indices. Negative indices. Indices. This is whereby you are given which are negative, and you have to work with them. You have to work with them the way they are. So negative indices. So with this one, we can look at I think one or two examples on the same. We can have our example 1. Example 1. So we have a to be 2 power 3, then we multiply by 2 power negative 3. Then B, we have 2 over 3, then we raised to negative 2, raised to negative 2. Then we have yeah, that one is enough for us to grasp the content of negative indices. So we can look at solutions. So let's work it from here. So our A here we have 2 power 3, then we multiply by 2 power negative 3. 2 power 3, and then we multiply by 2, 3. Now, this one is going to be much simple. We shall have 2. Using our first law that we looked at, we say that when we are multiplying numbers which have the same base, we are going to add the powers. Therefore, we add the powers, which is 3 plus negative 3. So we shall have 2 base 2, 3 plus negative 3, you're going to get 0. So any number raised to 0, we said, is what? 1. So our final answer becomes 1. So we said that one at the beginning. Any number raised to 0 is 1, and any number raised to 1 is still that number. Okay, now we can move to next example B. Example B. Now example B says that 2 over 3, 2 raised to negative 2, raised to negative 2. So this is how what we have. So when you have such, you can see we have this is raised to a negative what? Power. So having then a negative power, for you to move this negative sign, you have to reciprocate so that you have 1 over 2 over 3. Then the negative sign now disappear, and then you remain with power 2. So when you reciprocate, the negative sign disappear. Now you work the denominator, so you have 1 over 2 squared, you get 4 over 3 squared, you get 9. How do we remove this this denominator? Now that is a fraction, we remove it from the lower side. You simply take 1 times the reciprocal of the fraction, which is 9 over 4. So 1 times 9 over 4, you're going to get 9 over 4. So 9 over 4 is the same as 2 and a quarter. So that one now becomes your answer for that question. So if you have a negative number or a negative power, you have to find the reciprocal for you to do away with the negative sign, so that you remain with a positive power for you to work it out well. So in general, let's say A over B. Then you raise it to a negative number. Let's have it as negative n, negative number. Your answer will become, now that you reciprocate, now you shall have B over A. Then when you reciprocate from A over B to B over A, the negative sign disappears. Therefore, you have your n. So if you have this law, you can still work some indices that have negative powers. So with this, it can help you somewhere when you have negative indices. You can use this formula or law to work it out. So we can look at on fractional indices. That was negative indices. We can have a look at fractional indices. Fractional indices. So this one now is these are now fractions. Have some few examples on such so that we see how it's done. Fractional indices. So we have these examples. Let's have these examples. We have A, 27 power third. Then B, we have 16 power third. And C, 4. Then we have a negative half. Negative half. So we have to work these ones out. You can see all the indices are fractions. And they are fractions. And one of them is still a fraction, and it's still a negative indices. A negative and still a fraction. So we shall look at it, see how we are going to deal with that in our solutions. So we can start with A. You can start with A. So A, you can from this space. You can have our A here. So we have 27 raised to a third. And then we have to solve it. 27 raised to a third. Let me see. It's not it's raised to a third that way. Now, for you to work this one out, you have to simply, if it's raised to a third, what you have to do, you simply find the cube root of that number. That is how it is done. You simply find the cube root of 27. 27 raised to a third, you simply find the cube root of that 27. So cube root of 27, we all know that it's what? It's 3. we know that the cube root of 27 is 3. Then that is how you solve that one. Then you move to B. We move to B. B, we have 16, 3 over 4. 16 raised to 3 over 4. Now, when you have this one now, it's somehow not that much different, but this is how you're going to deal away with it. Now you can see the base or the numerator, the denominator of that fractional indices, which is 4. This is what you do. You find the fourth root of the base. Now the numerator of your fractional indices, you now make it power 3. So you get the cube root, the fourth root of 16, then you raise it to 3. So that is how you solve that one with 3 over 4. So the numerator of the indices, you have to make it the power, but now the denominator fourth root of your. So with that, we can find the fourth root over 16, which is 4, which is 2. I mean, fourth root of 16 is 2. You can use your calculator. That is 2. Then you now raise it to what? Raise it to 3. Now, 2 raised, you're going to get 8. So that is how you simply do that one. Same applies to other fractions of the same. And then we go to C, and C was 4 raised to negative what? Half. Now we have 4 raised to a fractional indices, which is a negative one. So in this case, what we said on a negative test, we said that for you to do away with negative sign, you have to find the reciprocal. So we find 1 over 4.5. That is what we said. Then you move to the next step. Now work out using the fractional indices. 4.5 now is the same as the square root of what? Of 4. So we have 1 over square root of 4. So that one will give you 1 over the square root of 4 is 2. So that one brings you to the end. So you have your answer as a half. You have your answer as a half. That is it. That is how we work those ones out. You arrive at that answer. Now, look at this. We can say this. You can write this one in general. In general, A raised to 1 over n is equal to, now n, you take the nth root of A to be your answer. So A 1 over n is equal to nth root of A. And still, as we've applied in example 1, have that one. Then we have another one. Another one which is A 1 over A. So we have A 1 over N, then M A M over N, which is the same as nth root of A raised to M. So you can use this one, these formulas can help you. I can those who are following, we have Johnston Gula, I can see you. We have Damaris Juma. We have successful dreamers. You are following. Then we have Anne Katundu from Muka Girls. I can also see you. You are following. Thank you for that. I can see we are together. So this is what I was saying. In general, now applying those ones. A 1 over N is equal to nth root of A. So the way we've applied it here on our example A. Then we have this one now, A raised to 1 over N, then we multiply by M, is the same as A raised to M over N, whereby M over N, you take the denominator of the fraction, which is N. So you find the nth root of the base, then you multiply by, then you make M, which is the numerator of the power, then you multiply it as your new power. Then that is how you arrive at your final answer. So you can have that for your future reference, and it will help you. Now, I think that is what I can have for indices, and I think we shall have something on logarithms so that we can connect indices and the logarithms in our next class. So something to take home, you can get this exercise so that you can do on your free time. So you can write this exercise. You can try so that you can see if you've understood the concept. So number 1, you can say find the numerical value A. We have 8 raised to negative 5 over 3. So you simply apply the laws that we've discussed. Then you have 40, 96 raised to negative what? 3 over 4. So you still apply the same. 7 and a third. Then we multiply. Then lastly, the last exercise number 3. These are for you. You can attempt at your own free time. solve each of the following equations. So we have A. These are the things we've looked at. You only need to apply what we've said. Now it's equal to 81. Then our second one, in number 3, we have 3 raised to 4x. 3 raised to 4x, and then divide it by 3 raised to -7 will give you 3 raised to 15. Then the last one, 2 raised to x over 4 is equal to 8. That is good. So you can solve those exercises at your own free time. And then you can always get us on this channel. They are sending grades. I can see those from St. Joseph's Girls, Kibwezi. Thank you for joining us. So thank you everyone for being part of this class. We shall keep you updated. You may simply subscribe to our channel. Your own good. So thank you for today and have a lovely night.